Okay, hello Integrated Science, it's Mr. B, and this should be our last video for this year. Again, fingers crossed here that I don't do anything crazy, but last video here, so it's our last explanation for groups of stars, and we talked about clusters of stars, and now we're going to talk about a word that might be a little bit more familiar to us, and that's how stars can be associated in what are called galaxies. So there are different types of galaxies. There's what are called spiral, barred spiral, elliptical, and irregular galaxies. So what a galaxy is, it's a huge group of individual stars, star systems, star clusters, dust, and gas that are all bound together by gravity. There are billions of galaxies in the universe, and the largest galaxies consist of more than 1 trillion stars. Again, they vary widely in size and shape. Again, they're just massive amounts, of of stars, star systems, clusters, dust, gas, all these different things. Um, the first type of galaxy that we're going to talk about is called a spiral galaxy, and these have a bulge of stars at the center with arms extending outward like a pinwheel. And we'll see a picture here in a second to kind of help you see if you don't know what a pinwheel is. It's a thing you put on your bike and they blow in the breeze and it spins around. Um, these spiral arms contain gas, they contain dust, and they contain many bright young stars. The Milky Way, which is our galaxy, is in fact a spiral galaxy. Um, and then there are some spiral galaxies that have a bar through the center with arms extending outward from the bar on either side, and these are called barred spiral galaxies. So if you have a bar going through you and you still kind of have that spiral shape, you're known as a barred spiral galaxy. Again, there's going to be pictures of all of these kind of in a moment, so we can kind of explain a little bit more when we see those pictures. Then we have what are called elliptical galaxies, and these are more spherical or oval shape with no trace of the spiral arms. Again, we talked about the ecliptic plane being the fact that planets have more of an ellipse or an oval shaped orbit, so elliptical galaxies are more oval shaped or more circular shape, and they can come in a wide range of sizes as well, and they have very little gas or dust between the stars, and they usually only contain older stars. So again, they contain a little bit less material. Again, that's why the arms of the spiral galaxies where a lot of those that dust and gas on stars are contained, and that's not present in our elliptical galaxies. And then on our last type of galaxy, we have what are called irregular galaxies. So a small fraction of all galaxies are known as irregular galaxies, and they are called irregular because they have a disorganized appearance. They have many young stars and large amounts of gas and dust. They come in many shapes. They're typically smaller than the other types of galaxies, and they're often located near larger galaxies. So irregular galaxies could possibly still be forming, have new additions, and that's why their shapes are kind of so different compared to the other ones. So here is a picture of a spiral galaxy. This will give us a little bit better understanding. So we can see here at the center we have the arms coming off there, again coming in that spinning pinwheel shape there. Again, if you look at it from the top, it almost looks like you're going down into like a tornado or something like that. So that's a spiral galaxy. And then right here we have a barred spiral galaxy. Again, see, might be a little bit easier to see the bars if I find a little bit of a better one. Again, zoom straight up and down right here. We have the bar going through the center of it, then with our arms kind of going off there. Again, where this one's kind of more circular at the center, this is kind of more of a bar shape there in the center. And then we have the ecliptic galaxy, again, more of a circle, oval type shape. And then we have our irregular galaxy. Again, there's many areas of star formation, which probably, again, gives its irregular shape. Again, this one almost looks like it could be similar to possibly our spiral galaxy right here, but you can definitely see that there's clusters kind of all over the place and no real regular pattern there. So those are our 4 types of galaxies, and then to end it up, we're going to talk about our own galaxy because, again, it kind of just makes sense to study the one closest to us. The Milky Way has an estimated 200 to 400 billion stars, and then its diameter is more than 100,000 light years. So just huge, huge area. Again, very hard to comprehend how huge that actually is. Every individual star that we can see with the unaided eye in the sky is our galaxy. So when you look up into the star, when you look up, when you look up to the stars, when you look up at the sky at night, all those stars you see are members of the Milky Way galaxy. The solar system lies in the Milky Way's disk within a spiral arm about 2/3 of the way from the center. So that's our location of the Milky Way. We're in an arm about 2/3 of the way from the center of our Milky Way spiral galaxy. in a side view, the Milky Way appears to be a flat disk right here on the right there. And then the overhead view is where they kind of get that spiral shape here. And then there's all what we call the nucleus, which is the center. Again, we have our solar system right here, which is about 2/3 of the center. Again, one of our central arms there. Again, you can see there we have spiral arms containing many young stars. Again, that's just from the side. Again, from the side, it almost looks like Saturn or something, or almost kind of looks like a spaceship from the side there. Again, the central bulge is where the older stars are. Again, the new stars are going to be formed kind of on the outside there. The Milky Way's flattened disk shape is caused by its rotation. It takes about 220 million years to complete one orbit around the galaxy center. And recent evidence suggests that there is a massive black hole at our galaxy center, which could be sucking up mass and everything like that. But again, we don't really know exactly what's going on in those black holes. But we do know that the stars are forming in the galaxy's spiral arms. So again, the center is kind of the older area of our solar system. Again, that kind of makes sense because the center is what always forms first. And then the stars form in the galaxy's spiral arms after that. So, and then the last thing we have there, what are called quasars. By studying their spectra, again, the colors, again, spectra, remember, colors that they absorb on a color spectrum, astronomers have determined that quasars are the enormously bright centers of distant young galaxies. They produce more light than hundreds of galaxies the size of the Milky Way. Again, and the reason why they're so bright is that it involves matter spiraling into a supermassive black hole with a mass of 1 billion suns. So there are areas out there, again, that's just kind of one kind of new thing there that, again, there's just massive amounts of energy going on there that we don't really have, again, any idea of how much is actually going on, but again, they're so bright that we believe, and they have so much energy that there's just matter that's constantly being sucked into the supermassive black hole with a mass of 8 billion suns. So that's just kind of a little bit scary to think about. But I believe, yep, that is it for this year, if again, if we don't do anything crazy. So let me know if you have any questions.